In this video, we're going to take a look at how we can configure and apply a quality of service policy to a Cisco router. And the way we typically configure quality of service is using a three-step process. This is called the MQC process for Modular Quality of Service Command Line Interface. So MQC. The three-step process begins with the first step, which is the creation of class maps. You might remember from a prior video, we discussed how Cisco recommended that we create no more than 11 different categories of traffic in which to place our traffic. Well, those categories are created with class maps. So let's create a few of them here. Let's go into global configuration mode with the configure terminal, and let's create a class map that's going to match email traffic. Now, with email traffic, we have different protocols that will be categorized as email. We've got POP3 and SMTP and IMAP and Microsoft Exchange. I want to be able to match any of those. So I'm going to have multiple criteria within this class map to say match any of those. And it's important to know if you're trying to match on more than one characteristic, there's some Boolean logic at work here. Let me show you what I mean with some context-sensitive help. We can do either a match all or match any. And here's a huge point. The default is match all, meaning that if I say match POP3, match SMTP, and so on, in order for a packet to be categorized in this class map, it would have to match all of those criteria. And that's not possible. We cannot have a packet simultaneously be a POP3 packet and an SMTP packet. What I need to do in a case like this is to use the other logic of match any. If I match any single criterion, then the traffic is going to be placed in this class map. So I'm going to say class-map match-any, and I'm going to give my class map a name of, I'll say email. And you don't have to make it uppercase. I think that's a best practice to make things that you create, things that you're giving a name to within Cisco iOS. I think it's good practice to make those uppercase. That way, when you're looking through the configuration, you're going to be able to see something in all uppercase, and you're going to say, oh yeah, that's something that I created. That's not some sort of a Cisco iOS keyword. Now, notice I'm in class map configuration mode, and there are lots of ways that I can match traffic. I could match based on existing quality of service markings. I could match based on the ingress interface, just so many things. But here's my favorite though, it's match protocol. And if we give some context sensitive help here, you'll see that Cisco iOS automatically knows how to recognize a plethora of protocols, including all the different email types that we're looking for. So what I'm going to do is say match protocol, and I'll follow that with POP3, and I'll give the command again. This time I'll follow it with SMTP, then we'll do IMAP, then finally we'll do Exchange. And we've created our first class map. And let's exit out of that class map configuration mode. Let's create another class map for voice traffic if we want to give it high priority treatment. We talked about the low latency queuing approach where we could put voice and maybe video traffic in a priority queue that gets to go first. Well, let's recognize that voice traffic. I'm going to say class-map, and I'm going to recognize voice traffic, so I'll call the class map voice. Now notice, I did not say match any or match all. And that's because I'm only going to give one match statement. There's nothing to compare it against. So the Boolean logic really doesn't matter in a case like this where I just have a single match statement. And I'm going to say I want to match the protocol of RTP. Remember we talked in a previous video about the real-time transport protocol that carries the voice and also the video media. And we could stop right there, but this match statement would actually match voice and video. If I wanted to just get voice, I could be specific and say RTP audio. Let's exit from that class map configuration mode and create another class map. I'll say class-map, and this will be for our more undesirable traffic. I'll call it our scavenger traffic. And let's say that we want to recognize maybe BitTorrent traffic. And yes, I know that a lot of companies use BitTorrent for very legitimate file transfer purposes, but come on, some people don't use it for those purposes. So let's say that in our particular business model, we don't want BitTorrent, or we want to limit it anyway. I'm going to say I want to match the protocol of BitTorrent. And we'll say that that's enough class maps for now. That was step one of MQC, the creation of class maps. Let's go on to step two, which is the creation of a policy map. In a A policy map, we're going to go into policy map class configuration mode for the different classes we created, and we're going to say what kind of policy we want to apply. So let's create a policy-map statement, and we'll call the policy map demo. And if I give context-sensitive help, you'll see not much happens within policy map configuration mode. The real magic happens within policy map class configuration mode. I'm going to say class followed by one of the class map names that we just created. Let's start with email. And notice we're now in PMAP-C, that's policy map class configuration mode. And this is where we apply most of our quality of service policies. This is where I can turn on policing or shaping, I can do marking, I can do class-based waiting fair queuing or low latency queuing. Just about everything can be done quality of service-wise in this configuration mode. And for the email traffic, I don't want it to be priority traffic, but I want to give it a certain bandwidth guarantee during times of congestion. And let's say that I decide on 512 kilobits per second. I'll say bandwidth 512. Now what that means is, during times of congestion, I guarantee that this traffic is going to have at least 512 kilobits per second of bandwidth available to it if it needs that much, and more if it needs more, and more is available. Now let me say that again. I worked really hard on getting the wording very specific there. I'm saying with this command that we want to guarantee that even during times of congestion, that this class of traffic can have at least 512 kilobits per second. A lot of people think when I type that command in, I'm limiting us to 512 kilobits per second. That's not the case. This is my minimum bandwidth guarantee. But I said I'm going to guarantee that we can have at least that much if we need it. If we don't need it, we can let somebody else use it. Remember, this is not the strict QoS model. This is the less strict model. This is the diff-serve model. So if we don't need bandwidth for this class map right now, we can let somebody else have it that might need it. So we're going to guarantee at least this much bandwidth if it needs it, and more if it needs more, and more is available. And now that I've turned on class-based weighted fair queuing for this class, I can then optionally turn on weighted random early detection. And I say I can now turn it on because before you can configure weighted red for a class like this, you first have to either configure class-based weighted fair queuing or shaping. And I've configured class-based weighted fair queuing, so now I can, if I want to, configure weighted red. And to do that, I'll say random-detect. And if I pressed enter right there, that would turn on weighted random early detection. And we talked about the different thresholds that we have with weighted red. We're going to say for a particular priority marking, there's a minimum threshold. Let's say it's 20 packets for a particular marking. And until the queue depth gets to 20 packets, then we're not going to be dropping any of those packets marked with that priority value. But once we exceed 20 packets in the queue, then we're going to introduce the possibility of discard. And that probability that we're going to discard a packet is going to increase and increase and increase until we get to a maximum threshold. And if we surpass that maximum threshold, there's a 100% probability of discard for that marking. Now, just by saying random-detect and pressing enter, it will do what I just described, but it will do it for the older IP precedence markings that use only 3 bits for a marking, not our DSCP markings, which use 6 bits, which is probably what we're going to be using today. So it's important that we, in most cases, say DSCP-based. That's going to apply default minimum and maximum thresholds to specific DSCP markings. Let's now configure our voice class. We'll say class space voice, and I do want this to go first. I want to give it priority treatment. I'm going to say priority 256. And what that says is traffic in this class gets to go first, and it can use as much as 256 kilobits per second of bandwidth, but no more. So unlike class-based weighted fair queuing, where we said we can have more if we need more and more is available, we don't want our priority traffic to potentially starve out anybody else. So not only are we saying, yeah, you can have as much as 256K, we're saying you can have no more than that because we want to starve anybody else out. And here I'm putting voice traffic in a priority queue. What if I had another class map? We didn't create it, but what if I had another class map for video? For video, I could say priority 512 perhaps. What would that do? Would that put it in a different priority queue? No, here's another huge point. There is one and only one priority queue. And if we put both voice and video into a priority queue, they're sharing the same one and only priority queue that we have. All right, let's go into our scavenger traffic now. The traffic that we're not particularly fond of. I'll say class scavenger. And here I want to set a speed limit on how much bandwidth we can use. And I could do that with policing or shaping. Cisco recommends we use policing on higher speed interfaces, and I'm going to be applying this to a gig interface, so I'll use policing. And we'll say police, and there's lots of options that we can play with here, but just the default behavior is this. The units of measure are in bits per second, by the way, not in kilobits per second. I'm going to say police 128,000 bits per second, so 128 kilobits per second. And just by pressing enter without giving any other parameters, here's what that does by default. It says that traffic in the scavenger class that tries to exceed 128K, it's going to be dropped. Traffic that does not try to exceed 128K, it's going to be allowed. And that's the creation of policies for the class maps we created. By the way, there is another class map I didn't tell you about. By default, we've got another class map called class-default. It's there by default. We didn't create it. We cannot delete it. Think of it as the catch-all class map. If we don't specify traffic to go into one of our class maps, then by definition, it's going to go into the class-default class map. So when Cisco says don't create any more than 11 classes of traffic, we could still have 12 classes of traffic. The 11 that we create plus the class-default that's there by default. And a best practice recommendation for that class-default class map is to turn on something called weighted fair queuing. Now that's an older queuing mechanism, but it tries to make sure that no one data flow takes over and dominates the available bandwidth. So it's generally good practice to turn that on within this class that we didn't even create. And we can go into that class map by saying class-default. And I'm going to say fair-q. That turns on weighted fair queuing. We've now done step 2 of MQC where we've created our policy. Now let's apply our policy. Let's go into interface gigabit 0/2, and we typically apply a policy to an interface. And the way we do that is say service-policy, and we can say, are we applying this as traffic is coming into this interface or as traffic is leaving the interface? And it's important to note that some of our quality of service mechanisms don't work in either direction. For example, I've configured class-based weighted fair queuing, and that's only going to work in the outbound direction. So I'm going to say service-policy output, and the name of my policy was demo. And we're done. Now, to verify this, there are different verification commands. You can do a show class-map, a show policy-map, but my very favorite and probably the most powerful command to do our verification is show policy-map interface, followed by the interface identifier of where we apply the policy. We'll say 0/2. And notice the output that we get. It tells us the different classes we created. It tells us how we categorize traffic into those different classes by matching POP3 or SMTP or so on. And we can see if we have any traffic. Now here in this demo network, I don't have traffic passing through this interface, but if we did, we would be able to see actual packet and byte counts to indicate that traffic really is being queued into these different queues. And that's a look at the 3-step MQC process for quality of service configuration.
Готов ли, Гепард?